Hi guys, welcome to our next video about method of central tendency. So in the last video we have discussed about different types of data. So it's a small reminder of what we discussed in previous class. So we have discussed that what kind of data we have and what kind of data we often use in statistics and machine learning as well as deep learning also. So we have discussed a lot, right? Which data goes to which statistical method, and we have discussed in depth on the topic. So if you missed the video, just check it out. It's my previous video. I will share the link in the description. Okay. So today this video we will go to the method of central tendency. So you may be worried about that. What Sarvin you are telling is measure of center tendency. It's a long word. It's a wide word. What's you thinking about that actually? So actually, it's a simple thing. So it is the basic foundation of the part actually. Okay. So if you don't understand the measure of center tendency, so it is very tough to understand the in-depth thing like mode, median, or standard deviation. Like that is the inference statistics. That's part of um, measure of dispersion. Okay. In this session, we will look about measure of central tendency. Okay. So measure of central tendency is about like here's the no part. So what is measure of central tendency? Okay, it is the common term. Okay, in statistics, central tendency is a central or typical value for a probability distribution. So it is a tricky interpretation when you are hearing the first time or you reading the first time. So you may get confused about what is the things are is going on. So in statistics, central tendency is a central or typical value or a probability distribution. So let me explain these things. Okay, this is the photo I get from the Wikipedia. So let me measure of central tendency. Okay, so it's mean that we have three types of measures of central tendency, like mean, median, mode. Okay, so what is a mean, median, mode? Okay, let me describe what is measure of central tendency. Okay, so you know that this is the normal Gaussian distribution, right? So this is a normal Gaussian distribution. So we need to measure the width. Okay, so this area we need to measure the width. Okay, so like we have a vertical areas there, but our main focus is to measure the width is there, like for measuring the width. Okay, so like measuring the width, the horizontal area. So measuring the horizontal area, this part to this part. Okay, so this is the measure of central tendency. Simple like that. Okay, measuring the horizontal part of the distribution. Simple. Measuring the horizontal part of the distribution what we have. Okay, so that is the measure of central tendency. Okay, so we have three types of central tendency here. Okay, so one is median, mean, another one is median, another one is mode. Okay, so it is like see here it is the Gaussian distribution. So we will look on Gaussian distribution after some time. So just consider this a own kind of distribution. Okay, it's a own kind of distribution. So in the distribution there is mean, median, mode. Okay, these are all the types of central tendency. So we are going to have a deep discussion about mean, median, and mode. So in this video, I particularly going to talk about the mean. What is mean? And how to calculate the mean, and how to interpret the mean, and where to use mean, which kind of data, and what kind of data we use for mean actually. So we are going to have a deeper session on this mean. So just sit, relax, and enjoy this lecture. Okay. So first, what I'm going to tell means mean. Okay. In this video, we are going to look at the mean actually. So what is mean actually? So before going to mean, just look at this picture. Okay, just look at this picture. I will have a question on this end of this video. Okay, so just check the blue color is mean, right? So where is the blue color? See here, this part, this part. Okay, so this is the mean, and this is the median part, and this is the mode part. Okay, if you are seeing in the first time, you may be tricky part is for you tricky. So uh, just see this part, then after the end of the video I will go to this, and you are going to interrupt this, not I am going to interrupt this. You will easily interrupt this for you. Okay, so let's go to the mean part now. So mean. Okay, this is the mean. We are going to see about the mean. we have three types, right? Like a main, median, mode. For we are going to see the first type actually. So what is mean actually? It's just an average value of the data. So what is the average value? You can tell us this average. What is the average? Okay, so just consider we have a data set like this is our data set like it's starting from 0.0 to 2.2. Okay, so what is the average value? So uh, average value is that let me tell. So in simple words, like I have 10 rupees. Okay, what is the average value of 10 rupee? You may tell is 5. uh, it's right when you are telling what is the average, it's right, but we have a separate formula for averaging. So you are telling 5, it's a middle value. That's a next part of median. Okay, we will look on median next part. So what is mean actually? So mean is also refers central part, but it is indirectly referring as the center of the data. Let me explain these things clearly actually. So just a thing, if you know about the average, it's okay, it's pretty much fine, but I will explain what is average clearly now. Okay, so it's just an average value of the data. Okay, so this is the formula for finding the mean. Okay, so first we will find the mean. Okay, then you can easily interrupt that mean actually. Okay, so a formula is like m. Okay, m is for mean actually. Okay, m is for mean, and sum of the terms divided by number of terms. What is the sum of terms actually? Sum of the term means summing all the data what you have. Okay, so sum means adding all the data what you have. Okay, so number of terms. It is oftenly refers normal n, like a normal n. Okay, so it is often refers as n number of terms. Like if you have 20 types of 20 number of data, so it is the total number of terms. Okay, let me go and let's go and calculate the mean from now. Okay, so let's calculate the mean here. Okay, so this is a formula, just look at the formula. If you forgot the formula, just look at the formula. So on sum of the terms divided by number of terms. Okay, so it is my data set, like n is equal to my number. It is not a number of terms, it's a data set, like number. Okay, so we have data like 1 4 6 7 9. Okay, so let's go to the first thing, like sum of terms here. So I'm going to the thing, the sum of terms here. Okay, so what is sum of terms? Sum is simply adding the term, right? So I'm just adding 1 plus 4 plus blah 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 9. Okay, so I'm just adding the term. Okay, so then I'm just going to the number of terms here. So number of terms means how many number of data we having. Okay, so I have 1 2 3 4 and 5. So I'm referring the 5. Okay, so just pause the video and try to calculate this mean. Okay, so I hope you have calculated the mean. Then let's go ahead. So is a formula. I'm just importing the formula here, like sum of terms divided by number of terms. So I'm just going to I'm just calculating the formula now. So it's 27. So, like 1 plus 4 plus 6 plus 7 plus 9 put a 5, then divided by 5 is 27. So the average value is maybe 5.4. Yeah, so 5.4. So this is the average value. So I have 27 total numbers. On the 27 total numbers, I have 5.4. Okay, so how do you interrupt the middle thing actually? So average is a separate formula. So if you need to calculate the average, this is a simple thing actually. It is a 5.4. But it is a simple thing, like it's a just number of sum of terms divided by number of terms. Okay, so this is all about mean. Okay, so in the data, in the statistics part, you will oftenly see this kind of distribution in every area. So you will impute it the mean when you are having a missing values in the data. So we will just impute the mean. Okay, so why mean is so important actually? So let me tell. Then before that, okay, what is the suitable data type for main? Okay, so in last video we discussed about the types of data, right? So I'm just giving it time, just pause this video and tell what is the type of data. Okay, we discussed the data, it's in-depth part, right? So I just want you to tell, just comment this video, this what kind of data is there, 14679. I'm not going to tell this. Okay, just try to give answer in the comment section. Okay, so I just want you to give the answer for 14679. Then like what kind of data? Not for 4679. What is the kind of data? Okay. So there is a specific condition if you are going to impute at the mean. So there is a specific condition. Okay. So there is a data type like interval and ratio types. Okay. So those guys like interval and the ratio types of data are most suitable actually. So nominal, discrete, and ordinal are also suitable, but it is not sensible. I have mentioned that it is suitable for remaining data types, but it is not sensible. Let's see why. Okay, so before that, I just want to say that this is a normally distributed data. So roughly normally distributed data. What is the mean of roughly normally distributed data? So it sounds like word term. If you don't know about the normal distribution, so we we have a video on the for the future. Okay, just be clear actually. So normally distributed distribution means just think that it is a distribution. It is oftenly used in statistics and everything, like a machine learning deep learning. It is often used in everywhere in the world. Actually, normally normal distribution is the thing. It plays everywhere. It plays in medical also. It plays in agriculture also. It plays in everything in the world. Okay, so just consider normal distributed is a random set, oftenly used things in statistics as well as everything in the world. So it is suitable for normally distributed data. Okay, if you don't understand this, don't do that actually. Just try to understand this interval and ratio types. Okay, mean is very suitable for interval and ratio types data types. Okay, I will try to explain why this is suitable for only interval and ratio data types. Why not it's suitable for nominal, discrete, and ordinal? Okay, so let's go ahead. Let's see why. Okay, here's the term. Why. So, okay, this is the part why this is suitable for only interval ratio. Okay, this is our question, right? So, first we will look at discrete data. Okay, we are nominal, discrete, and ordinal. Right? First, we will look at discrete data. Okay, so I'm just asking a question: is mean suitable for discrete data? So, okay, not sensible. It is not. I'm not telling it is not actually, but it is not sensible. It not make any sense. Okay, so okay, I'm just telling that average U.S. family has 1.9 children. Okay, so it is a discrete data. Okay, so how do you interpret the discrete data 1.9 actually? It is average. Okay, it is 1.9 is the average. Okay, so in the US, in the US country, so I'm just asking a question. I'm just making a survey to you. Okay, just try to pick a average children's in US. Okay, so you are going and making a random sampling in the US, making use of law of large numbers and central tendency, and you are try to come with the answer of 1.9 here. Okay, you are just coming with the answer of 1.9 here. Okay, so. It is a discrete data actually. It is a discrete data. Okay, son having like my no. Okay, let me think. If you have a if you are married, so you can tell I have one children, two children. You can tell I have 1.5 children, two children. Actually, it is not sensible. Actually, it is not valid. Actually, okay, like that is there. So if you have a discrete data, so if you are going to make an average for that, like a mean, if you are going to make a mean, so how do you interrupt the discrete data 1.9, 1.9? Actually, it give answer actually. Min can give answer, but it is not really sensible actually. I hope you understand the thing actually. No one have a children of 1.9. Uh, I think you can understand. Okay, so this is discrete type of data. Let's go to ordinal. So you know about this ordinal. If you forgot these things, just refer my previous video. I have explained this clearly actually. So same question. So is mean suitable for ordinal data? So let go to the thing like average course rating. Okay, so I'm just going to tell. I'm just telling to you. So just rate my video. Okay, so you can rate my video zero. You can rate my video like 0 or 1 or 2, 3. You can't rate my video 4.1 stars. How you can make 4.1 stars in the rating? Actually, you have 5 stars, right? So how you can making 4.1, 4.2, 4.3? Actually, it's not sensible. Ordinally, it means we have order data like 1, 2, 3, 4, 5. Okay, so we have order data. So how we can interrupt the ordinal data at 4.1? So, it can give answer actually. Ordinal data type, the mean can give answer, but the thing is that it is not sensible actually. Let's go to the next thing. We have discussed about discrete and ordinal. We have nominal, right? So we will go for nominal actually. So same question: is mean suitable for nominal data type? Okay, same thing I'm telling it is I'm not telling it's not. It is not sensible actually. So average person likes 1.7 ice creams flavor. Okay. So 1.7 ice creams. It is the average value. 1.7 is the average value. Okay. So I'm just giving a survey like one is equal to chocolate, two is equal to vanilla, and three is equal to strawberry. And I'm telling you to pick what is your favorite thing. You like chocolate. Then if you like chocolate means just click the one. If you like vanilla, just click the two. If you like strawberry, just click the three. Okay. So I'm just no. Conducting this survey for many people and came up the value like 1.7. So how can I interrupt like 1.7? I am go for vanilla or I might go for chocolate. Okay, so you can confuse, right? You know, we have a nominal data type, like it is a true zero rate, right? So it's a true 0 point actually. So you can tell it's a zero value actually. So that's why I'm telling it one is equal to chocolate, two is equal to vanilla, and three is equal to strawberry. Okay, so how you can interrupt. Okay, I'm came up with a value of 1.7. So you can go for chocolate or you can go for vanilla. So where do you go actually? So actually this is the thing actually. If you are calculating the mean, so the perfect data like interval. So if you have an interval data type, you can get the value of 1, 2, or 3. Like if you have a ratio data type, you can have a value, you can get, you have came up with a value of 2, 3, you can get a discrete solid value actually. So this is why I'm telling interval and ratio data types, ratio data types are perfect for more suitable, not perfect, it is more suitable for the mean. And like nominal, discrete, and ordinal are suitable, but it doesn't make any sense. Okay, so this is what I want to tell about mean, because most people can not covering this kind of area like in nominal, what kind of data type can suitable for mean actually. So this is also very important. If you are measuring, if you are doing a statistical thing in model building, so you just try to see these things. If you are imputing something with the mean, so just you need to look on which kind of data is that. If it is the interval or ratio, you can go for mean. Sorry, yeah, it's mean. If you have another kind of data like discrete nominal ordinal, you can go for another type of technique. Like we have a median, we have a mode. We can go for further any other. So you need to understand these things actually. So interval ratio are most suitable for nominal. Sorry, as for calculating the mean. Okay, so there is a failure scenario for calculating the mean. Okay, so you need to check if the data is following interval or ratio data. Then you need to check another one thing, the most important thing, right? So uh, let's go ahead. Yeah. So a failure scenario. Okay. So if you are going to measure your central tendency as a mean, you need to look at these things. Okay. So it has some failure condition. Like if you have a bimodal distribution, it gives mean, but it is not sensible. Okay. So what is a bimodal distribution? First of all, okay. So if you have a okay, so if you have this kind of distribution, like one peak, you can think like a mode is one peak. Okay, so if you have one peak, you can calculate the mean. Okay, you can calculate the mean. Okay, if you have two peak actually, like this, if you have a two peak, how do you interrupt these things? Okay, so let me interrupt this for you. So okay, so we have suggested only one peak in the front part of the video, right? Now we have two peak. Okay, so you can calculate the mean. So it will come here. Okay, it will come here. Okay, so it will come here. So it is also makes sense. You can get the mean, but it is not make any sense at all. Okay, it is not a complete final scenario. It is just a final scenario. So I'm just this is what I'm telling you. It has some failure condition. Like if we have bimodal distribution. Okay, so this is bimodal distribution. If you have only one kind of these things, like it is unimodal distribution. If you have two kind, it is bimodal. If you have three, four, it is a multimodal. Like yeah, it is a multimodal. Okay, so it gives mean, it will give mean, but it is not sensible. It not you can't interrupt this properly actually. Okay, so this is the thing I just want to tell that. Okay, so if you have a bimodal scenario, you can go for some other technique. Okay, we will discuss these things next video or next few videos. Okay, so conclusion of this video. Okay, in this video you have learned about what is mean and where to use mean and what kind of distribution mean must be follow. Okay, then okay, the mean is applied to interval and ratio data types. We saw about in depth and we have described these things clearly. And the mean of discrete normal data and discrete data, okay, and the ordinary data can be useful, but interpreted carefully. Okay, if you are going to tell your stakeholders or domain expert, you can interpret these things very carefully. Okay, so then it is that it is not appropriate. It is not really good for normal data. I have explained this why it is not good for normal data. Okay, so in this video we have discussed about the mean part in depth, and I hope you got some knowledge about from my video and this explanation, and I try to keep this explanation on future videos. Thank you guys. We will see you next video on the interesting topic of median. Keep learning guys. Bye bye.